Welcome back. In this video, I will discuss how to calculate Euclidean Manhattan Minkowski Supremum Distance. Also, I will discuss how to find the cosine similarity between two data points. In this case, we have been given 5 data points over here, that is x1, x2, x3, x4 and x5. We need to find the distance between these data points with respect to a new data point over here, that is x is equivalent to 1.4, 1.6 over here. Now we will try to find the first distance measure, that is Euclidean distance. If you want to find the Euclidean distance between two data points, let us say that P1 and P2, which is denoted by x1, y1 and P2 is denoted by x2, y2. The distance formula is square root of x2 minus x1 bracket square plus y2 minus y1 bracket square over here. And this is the new data point. This is the first data point. I want to find the distance between this new data point with respect to first data point over here. Just to make sure that you don't get confused, I have replaced that x1, x2, x3 to 1, 2, 3, 4, 5 over here. Now this is the first data point. You can say this one as x1 here, and this one you can say that y1, and this will become x2 and this will become y2 over here. So according to this particular formula, square root of x2 minus x1 bracket square. x2 is what here? 1.4. x1 is 1.5. So that is 1.4 minus 1.5 bracket square plus y2, that is 1.6 minus 1.7 bracket square. So every time this x2 y2 will remain same, but this x1 y1 will change here. So that is how you need to find the distance. Now if you put those particular values in this equation, as I said earlier, 1.4 minus 1.5 bracket square plus 1.6 minus 1.7 bracket square, you will get this one. Similarly, you will find all the distance over here. That is the distance between this new data point with respect to these 5 points over here. Coming back to the next distance measure, that is the Manhattan distance. If you want to find the distance between this P1 and P2, you need to use this particular formula. The formula is cardinality of x2 minus x1 plus cardinality of y2 minus y1 over here. Again the same thing. This is x2 y2 and this one is x1 y1. In the next case it will become x1 y1 and so on. So the first one will look something like this one. x2 is 1.4 and x1 is 1.5 here. y2 is 1.6 and y1 is 1.7 over here. Now if you find this, solve this equation, it will get 1.4 minus 1.5 is minus 0.1. The cardinality is plus 0.1 here. Similarly, 1.6 minus 1.7 is minus 0.1. Again, if you take the cardinality, it will become plus 0.1. If I add it, I will get plus 0.2 over here. Similarly, you need to find out the different measures over here. That is the distance between new data points with respect to 2, 3, 4 and 5 over here. Coming back to the next distance measure, that is Minkowski distance. If you want to find the distance between P1 and P2, again we need to use this equation. If you look at this equation, it is almost similar to Euclidean distance formula. In Euclidean distance, we used to take the square root over here. In this case, we have taken h. Again, in Euclidean distance, we write here square. That is the x2 minus x1 bracket square we used to write. In this case, we have written power h over here. Based on the value of this particular h, this particular formula will become different over here. So in this case, I have considered h is equivalent to again 2. If anything other than 2 is present, you need to get the different formula over here. If I take h is equivalent to 2, the formula looks something like this, which is exactly similar to our Euclidean distance. So the distance over here is so and so. Coming back to the next one, that is Supremum distance. If you want to find the distance between two data points with respect to Supremum distance formula, the formula looks something like this. That is the maximum of cardinality of x2 minus x1, cardinality of y2 minus y1 over here. Again the same thing, x2 is here, y2 is here, x1 is over here and y1 is over here. So if I put that particular thing, this is what we will get 0.1 here. Here also we will get 0.1. The maximum is 0.1 here. But in the second case, in this case we will get 0.6. Here we will get 0.3. The maximum is 0.6. So that is what the answer over here. Coming back to the last distance measure, that is cosine similarity. If you want to find the distance between 2 points, that is A and B, you can write the formula something like this one. Summation of AI BI divided by square root of summation of AI square multiplied by square root of summation of BI square here. Now the numerator looks something like this in the first case. This is, you can say that this point, you can say that A here, and this particular point you can say that B here. So summation of AI BI, summation of AI BI is nothing but what? 1.5 multiplied by 1.4 plus 1.7 multiplied by 1.6. So that is what I have written at the numerator side. Denominator is summation of AI square. AI is nothing but what? This one, that is summation square root of 1.5 bracket square plus 1.7 bracket square multiplied by, that is in between multiply we have, that is a bi square, summation of square root of summation of bi square, square root of summation of bi, that is 1.4 bracket square plus 1.6 bracket square. If I solve it, I will get this value. Similarly, if I solve the different values or different distance measures, I will get all these particular values over here. So this is how actually you can find the cosine similarity. In this video, I have discussed how can you find the different distance measures like Euclidean, Manhattan, Minkowski and Supremum Distance. Also how to find the cosine similarity between two data points. I hope the concept is clear. If you like the video, do like and share with your friends. Press the subscribe button for more videos. Press the bell icon for regular updates. Thank you for watching.